Yeah, I think instead of using the microphone, or instead of using the other mic, I can look into using a setup like this. Using this microphone to feed back into the output of the speaker. But the worst part of this is there will be a slight delay, which is really really annoying to some people, because you'll be hearing me, and then like within 50 or 100 milliseconds you'll hear the amplified version of the same thing. So sometimes it doesn't really work. It doesn't work out that well, if I do it that way. This mic also has a live output. There's one output that is live, so it's still recording. It's still whatever the mic is recording, but it's analog, and I can hook it up back to the amplifier. So I have to look into that route and see if I can do it that way. The other mic is not working with the wireless mic thing. It's just not working. I had another student who is a AV specialist, and he looked at that and like, he cannot get it to work, because I think it has to do with some of the setup issues. So anyway, we are getting started with today's lecture, and it's going to be an interesting one, especially if you're interested in how to get to a database remotely from your application. Okay, so this is a really kind of interesting discussion, and I have already highlighted the portion of the notes here. It's not exactly in the right order, but I think last time I kind of said that I would talk about remote database access today, and that's exactly what we're going to do today. So we'll go ahead and take a look at the general approach first, and then we'll talk about some really specific stuff with examples that you guys can follow. Okay, so there are several ways to do it. The first way is to use a database engine. In other words, you have your application to open a connection directly to a database that is living on a server somewhere else on the internet. It is possible, okay? You can open a port and talk to something else. However, it is not a recommended way to do it. Okay, sorry, no soft drink, please. Okay, the worst part about this approach is if your app gets compromised, it is possible to have the entire database open to whoever is doing the attack, or have possession of your application or your mobile device. So this is definitely not encouraged. Okay, do not try to open a direct connection to a database, because if anything gets exposed, your entire database is exposed. The second method is to use the Google Fusion table. I'm not going to talk too much about it, because App Inventor already has a component for it, and also a tutorial to kind of guide you through step by step how to do it. So for people who want to use a Fusion table, go ahead and do it this way. It is already kind of supported, and it is documented as well. So what I'm going to focus on is a custom web interface. In other words, it is your web interface, it is your server, it is your website. Okay, so how can you have your own website and still be able to use your app to access data from your website? Now, this approach has a few advantages. One, everything is under your control. So you can basically say, I want to expose like this much of my database, or you can say, I want to expose this much of my database. It is entirely up to you to decide how you want to expose the database. In other words, if you want to say, okay, if it's coming through the web interface, I want everything to be read-only at the most. Okay, I don't want anyone to be able to modify the database. I want these tables to be protected from the web server perspective. You can do that. Okay, you can set up permissions in MySQL or PostgreSQL or Microsoft SQL to basically designate certain tables to be inaccessible to the web server. So that way, even if someone is to hack into the application, and certain tables will still be inaccessible. Okay. So that's why I really like this approach a lot, because it offers a lot of flexibilities. On the application side, what we'll be doing is to use the web interface or the web component, as App Inventor calls it. It is called a web component. What it really is a component that can talk to the web using HTTP or HTTPS. It is actually capable of using HTTPS, but there's a caveat to that. We'll talk about that later. On the server side is, you kind of have to do some work on the server side. On the server side, you will have to write, a web script or web scripts in many cases, and that can be done in PHP. For people who are interested in this, after today's class and say, well, I really want to do this, but I wish we could spend more time on PHP and stuff like that, go ahead and take Carol Lever's CISW410. Okay, the 410 class is the PHP class, and she will talk about how to write PHP scripts that can talk to a database. What I'll focus on in this class is to give you a very simple example of what you can do to generate documents or content that is easy to parse on the application side. So that would be my focus in this class. You can also use Perl. My examples are all in Perl and not in PHP because I'm just a whole lot more familiar with Perl. And you can use Python, Java, and many other programming languages as well. The approach is pretty much the same. It's just that you're using a different programming language to get it done. What it does, what a web script does is it translates an URL, a universal resource locator, which is basically what we call a request, okay? An HTTP request to the underlying database commands, and it can send requests to a local database and respond with the results. Okay. Now, unlike a normal web script where you will spend a lot of time on CSS, cascading style sheet, you will have to spend a lot of time to make it look right, make things format correctly. From our perspective, because the content is going to be communicated to your own application, so all we really want is just comma separated format. Okay, just give me the raw data. Your app written in App Inventor will be responsible to format everything and do all the user interaction. That's basically the bottom line. So you don't have to spend a lot of time on formatting. Just give me the raw data. On the other side, on your app side, you get to decide how to display everything with buttons, images and whatnot. And that's basically what the second paragraph talks about. Unlike a typical end-user-oriented web script, this one only needs to spill out data. Okay. In fact, the less formatting you do, the better, because it makes it easier to parse the data, so that your app written in App Inventor can basically chop up all the data into the components and display or make use of the data accordingly. Now, this approach is really, really flexible because you have control over both the application side and also the server side. So that means if you want to push all the logic onto the server side, you can do that. Okay? If you want to push all the logic, but most of the logic on the app side, you can do that as well. So you get to choose, where your app running on the mobile device meets the server, which is running the web script, and you can shift, the responsibility one way or another, depending on which side you feel more comfortable with. It also depends on a few other factors like security, and what type of exposure do you want to handle from the database perspective. And that's basically what the next few sentences talk about here. You can also make it so that hacking the app side does not automatically expose the entire database, because you can basically shrink that interface to very small, so that you don't have as much data exposed. So that's just a general discussion of how to get remote data from your App Inventor program or application. Are there any questions about what we have talked about so far in today's lecture over the past 10 minutes or so? Questions? How many people have some experience writing web applications or web scripts? So there are quite a few people who are already with some exposure. How many people think that you might be interested in doing that? Okay, so for those of you who think that you might be interested, I would definitely recommend CISW 410, which is our server-side scripting class. You haven't taken that one yet?
I've taken it. I'm tutoring for it this semester.
Oh, great. So that would be a good integration between the two classes.
Are any of these still open by chance, or second 8 week maybe or something?
The CISW 410 is a full semester class.
Okay.
So there's no second aid, unfortunately.
Okay.
I think that it might be offered every semester.
Okay. How about the follow-up to this? The 363 is it?
363 is not scheduled for spring because I think we are basically taking two 362s and then offer one 363 because some people may take this class but not necessarily the next one.
Yeah.
Yep.
Okay.
All right. Any other questions? No other questions? Yep. Go ahead.
So the follow-up to this one is getting offered till next fall then?
That is correct. Yeah, because we may not get enough students if we are to offer 363 in spring. If we don't get enough students, the class get canceled. So you will still have to take it, like at least one semester later. But even so, then we may not get enough students in the fall of 2015. But if we combine 362s and then offer 363 once, we for sure will get enough students. So we're not going to waste the time of anyone in that case. So I understand most people want to have 363 offered like the next semester so you can get done and get your certificate. But the problem is if we did that we may end up having that class canceled, which is worse than having it offered for sure the semester after. Okay, so if there are no questions about this slide, any other questions about this one? Okay, we'll move on and actually do an example. Okay, so the next one is really step by step with screenshots and whatnot. You can tell from the thumbnail here, it's a rather long discussion because it has a lot of screenshots. So what we'll do is we'll have a mock-up HTML document. So the HTML document that is mocked up, this is a hyperlink, so you can open a new tab to the document itself, and that's all it does. Okay, this is an HTML document. It doesn't really do much. All it does is to print, value 1, value 2, value 3 as a comma separated output. And if you want to look at the actual, content, well, that's the entire content. Actually, it is an HTML document. You can also go to this page here. It has exactly the same thing. So I'm gonna right click here and just go there, and you can see that's the entire content. Now, if you look at this content here, you might think, oh, it is just a regular HTML document. It is actually not the case. So what I'll do is I'm going to log into the Power Server and then show you the actual content of what I call an HTML document, because it really is not an HTML document. So I'm going to go there first. And don't worry, I will have everything, discussed, also. So I'm going to show you exactly how to make a document like that. That is not a conventional document. Okay, well, this one turns out to be actually a conventional document. All right, so to get this application going, what we want to do is to have what we call a web component. So I'm going to do exactly this. Okay, in today's class, I'm doing interactively using AI2 at Inventor, and it's using, it doesn't matter which account I'm using right now, it will still work. Uh-oh. It needs a new companion. Well, we'll see. Maybe it will update correctly. So I'm gonna start up the AI starter from AI setup and go back here and see if it updates automatically. It should update automatically. And while it's doing this, we can go back to our notes here. And it used to be in other stuff. It's no longer in other stuff, because App Inventor 2 kind of changed things around a little bit. But after we get the emulator up and running, we'll go ahead and actually write this app. So this is what we want to do. If you want to follow along, this is what we're going to do. We have one button and 3 individual text boxes. The button is just one here to trigger the operation to basically say yes, go get me some data. The application will parse the output from the website and chop up the individual fields and fill in the 3 text boxes accordingly. So that's what the app is going to do. And let's see, it's still starting up. It probably wants to update itself. Nope, it's okay, it doesn't need to be updated. Okay, that's fine. Alright, so what we'll do is we'll start a new application. So we'll start a new project. I'll just call this project Remote Data. At the end of the class, I can download the application, turn it into an AIA file and put it onto Moodle. So this way, you guys can just, download it and upload it onto your own project, and you have all the source code of what we talked about today. So as we talked about a little bit earlier, we'll have 1 button and 2 text boxes. So we'll drag 3 text boxes into here, and we'll change the button, just so that it reflects what we are trying to do here. The text of the button is going to reflect what it does, which is to get remote data. And we'll also rename it so that instead of just calling it button 1, we'll say button get data. Click OK. So, kind of superficial changes, nothing really major here. And then we'll also go to connectivity to get our web component. So I'll drag a web component into the designer or the viewer part of the designer, and you can see that the web component has some default components here, allow cookies and stuff like that. You can use your application to change all of these. Okay, so there's no need to set any one of these properties ahead of time. Going back to the notes here, we are going to basically set the URL to that particular URL, the address, and then we'll use the web1.get method in order to get the content of that website. So let's go ahead and go to our app inventor here, switch to the blocks view so that we can actually specify the code. Switch to the blocks view. Everything is going to start with either the screen itself, which has ability to get started automatically, or use the button. In this case, this is the only reason why we have a button, is to trigger the operation. So we'll go ahead and specify the click event handler, and then we'll go to the web component here and say, okay, we want to get something here. So we'll go ahead and there are a few ways to do it. If you go through all the calls here, you can just do a get here. If you want to do a get here, you have to specify the URL first. So we can also set the URL right here to the web address that we were talking about earlier. So that's just a plain text here, but you can certainly make it more complex if you want to. But in this case, it's really just http power.arc.losbrios.edu /data.html. That's the URL to the data, and I have it already specified here, and it's just a copy and paste into the application. And then after this, I can ask the web component, now that it knows what URL I'm trying to get to, now is the time to actually make that request. So to make that request, I'm going to use a get call here. There are 2 basic ways to get content from a website. One is called get, G-E-T, and the other one is called post, P-O-S-T. Post is more useful if you have like a file to upload and stuff like that. Get is just easier for quick and short access to a certain website. Like in this case, I'm not passing any parameters, I'm not posting any data, I'm not uploading a file. So post is a little bit more troublesome to set up. Get is just a little bit easier. Okay, and that's it. Okay, that's all this button is going to do. But what are we getting back, or how do we process what we are getting back here? It's not done here. Okay. The reason why we're not getting here, in other words, when get web1.get comes back, okay, if I put any blocks after this, it will execute as soon as the request is transmitted. It doesn't continue when we get the reply back from the other side. Okay, let me say that again. So let's just say that I put something that is kind of silly here. Okay, I'm going to go to screen 1 and change the background color to something. Okay, now this one I'm just doing this as an example. Okay, so I'm just doing something really silly here. Okay, after the get block, I'm setting the screen color to purple, or it looks like fuchsia on my screen, but it doesn't look fuchsia on the actual projector. So the question is, when is the screen going to switch to the fuchsia background color? Is it right after I send the request out, or is it right after I get the reply back from the server? The answer is the former. In other words, as soon as the component gets the request sent out, the screen color is changed to fuchsia. The reason is simple. We don't want to wait in our own blocks for the other side to reply back. There's no telling whether the server is even there or not. Okay, so you don't want your app to hang up and go, okay, I cannot do a single thing now because I'm waiting for the other side to reply. We will just basically send a request and say, okay, we can now continue to do whatever we need to do. Okay, if you have something else to do, if you have any type of animation to do, you can go back and continue with whatever else you need to do, and your program, your application will still be interactive. It can still handle other buttons. You can still enter something into the text boxes, or do whatever you need to do. Okay, so now the question is, when is it gonna come back? I mean, when do I know that I get my reply back? If you go to the Web 1 component, you will see that it has several event handlers, 2 in fact. One is called got file. In other words, when you are requesting a particular file, then it will get triggered. But if you are using, when you're using get and you're just trying to get text back, this is what you're going to get. So this is an event handler because it starts with a when, which means when we get a reply back from the previous request, this block starts execution. Are we doing okay so far with this particular event handler? Because we are no longer dealing with something that the user triggers. We are now talking about something that the other side, the web server, is going to do. As soon as I get a reply back from the other side, this block starts execution. It is also parameterized because the first thing it comes back with is the original URL, which is the same thing here. Okay, the only reason why we have a URL here is because you can send multiple requests at the same time to different websites. So when they all come back through this block here. In order to find out, okay, I'm getting a reply back, but which reply are we talking about? Which request is this reply corresponding to? That's why we have the URL here. Okay, just so that your code can differentiate. If you have multiple requests sent out to different web servers, this is how you can differentiate and go, oh, okay, this is a reply back from that particular request. Now, since I only have one request here, there's no need to really process or check the URL. But if you have multiple ways to send or multiple blocks to set the URL and use the get call, you really should come back and check it. So what we'll do here is we'll go to the screen component and switch the screen back to a more sensible color. Okay, and we'll go to set screen. Where is it? Background color back to the original. So we'll go back to colors and set it back to white color here, and that's all we're going to do for now. Okay. Now this is a good application to test already because one, it can test whether I can actually get the request sent out. We'll see whether the screen will turn fuchsia for just a fraction of a second, and then we'll see whether the screen turns back into white as a background because it's supposed to, right? If I get the request back, I should have the screen turn back into the white background. So let me switch to the emulator now, and just give it a try, right? Did you see it blink just for a fraction of a second? Now, if you want to see it fail, you can certainly do that by changing the URL to something that is invalid. Okay, I don't think I have a data1.html document here, so let's go ahead and see how this one is going to mess up. So we'll get, oh, it still comes back, it comes back because the server it replies back and say, that page does not exist. In other words, the server is still replying. So in order for the server not to reply, let me change to a different URL here. Mess up the server name. So this will probably react differently. Yep. Because this time nothing is coming back. Okay. Is that okay so far? Does everybody understand why it is responding differently this time? Okay. In all the previous approaches, the server is there. I mean, power is up and running. When I try to request something that is not on the server instantly replies and say, it's not here. 404. Sorry. Okay. But in this case, I messed up the URL, the server side of the URL, which means that is not even server. Okay. I send out the request, but nothing comes back to even confirm and say that, oh, this website does not exist. It just times out, and we saw that little error messages, but I never got a reply back. The server never replied because there's no such server. Okay, so let me go back and change this back, just so that we don't, get that screen here. And I'll also fix up the actual path to the file, so everything is now good. And if I click, get data, the screen turns back into a white color. All right, so that is this is a good demonstration of what happens when you do a get and when you actually get a reply back, so they have something to process. Okay, this is called asynchronous processing, which means the time that you send out a request has almost nothing to do with when you're going to get a reply back. It's definitely not instantaneous. Okay, a lot of times when you do interactive programming, like what we are doing here, you have to deal with asynchronous request. In other words, you have no idea how long you have to wait to get something back. So if you want to catch that error, you can use a timeout. You can use a timer to basically say, if I don't get a confirmation that I'm getting something back within, say, 5 seconds, okay, my code, using my own code, my own logic, I will determine that the connection, for whatever reason, cannot be made, and this application is going to do something accordingly. Okay. I'm not going to do that with this particular program, but I'm just saying that if your application requires remote access to a database, you need to think about, but what if I cannot make that connection? What is this application going to do if I cannot make that connection? Okay, so that's good. What about the other stuff? Okay, get response code, response type, and also response content. They're all responses. How come they're broken up into 3 pieces? Well, let's talk about the first one first. Okay, get response code is basically, did we get something back? Okay, it's a number. 404 is a typical number when the web page does not exist, and then you have the usual OK, which I think is 500, 500, and then we have all the other extra code like server side error and whatnot. So we'll take a look at this code first and see, okay, let's see what we're getting back here.
200 is okay.
Oh, 200 is okay? Okay. So it's just a number. And if you want to get a list of all those numbers, you can get HTTP
And
response codes.
Wikipedia has the full list.
Which one?
Wikipedia.
Wikipedia?
And
Oh,
Wikipedia
first,
org.
or W3.
Third in the list has all of them. Yeah.
Okay, so you have 100 series is informational, 200 series is success, and then we have 300 series multiple choice, 400 series client side error.
Not good for 18. You'll like that one.
For
18.
For 18, I'm a teapot. And then we have 500 series here, and I'm suspecting core breach is one of those, right? All right. So now before you do any processing and say that, oh, okay, assuming the request is handled correctly and I get a correct response, don't make any assumptions. Okay, check the response code first. Okay, because if your response code is anything other than what you're expecting, don't do any further processing. Just report an error and say, okay, there's some problem here. I cannot continue processing. So right here, I'm gonna do exactly that. Okay, so I will go ahead and put in a conditional block, which is an if-then. Okay, and I'm gonna make this an if-then-else, which means if it is not what I'm expecting, I'm gonna do something to reflect that. Okay, and then the if here is to say, is response code what I'm expecting? In this case, it should be a 200. So if I scroll back to the 200 series, which is when everything is okay, a very typical response is just okay. Standard response for successful HTTP request. The actual response will depend on the request method used. In a GET request, which is what we did, the response will contain an entity corresponding to the requested resource. In a POST request, the response will contain an entity describing or containing the result of the action. In this case, because it is a simple GET request, we're getting the entire document back. We're not getting a file, we're getting the entire document. Right? So we'll go ahead and double check. Okay, are we getting 200? So in this case, we're comparing, and comparing a number with another number is a math operation. So we'll drag this equality or relational block here. We'll keep equal to. The first thing we'll check, or the first thing we'll use for the comparison, is the response code. So we put the response code here, and then the second one is really just a text, or excuse me, not text. It's just a literal number of 200. So we'll drag a number block and turn it into 200. So this way we can check whether the response code is in fact 200 or not. Okay, I'm not going to differentiate between the 400 series, the 500 series, and go on and so on. I'm just going to say, is it okay or not? Okay, that's the only differentiation I'm going to make. And what I'll do is I can't easily do that, unfortunately. So what I'll do is I'm going to turn the screen back to the normal color, but only if the response code is good. If the response code is not 200, I'm going to turn the screen to, let's say, a yellow color, as a warning. Sorry? Red warning. Well, yellow is good. So I'm going to go to screen 1. Well, no, I don't need to go to screen 1. Doesn't let me back up. There we go. We can just duplicate the block, stash it here, and then change the color to, let's say, a yellow color here. There we go. Okay, that's all I'm going to do now, okay? Because at this point, I just want to see, am I getting a response code of 200 or not, okay? So I'm going to go check the code by running this application again, get data. Nothing seems to happen because it's happening so quickly, okay? So you can see that it just blinked, into future mode and then go back to white mode. And according to this code here, I am getting back a code of 200, and that's why it turned back into a normal color, okay? Some of you may say, well, but I'm not 100% sure. Well, let's go ahead and mess it up. So instead of using data.html, I'm gonna go get a file that it does not exist on the other side. And this time, it basically turned into a yellow color, which is exactly what the code is supposed to do, because data1.html does not exist on the server. So as a result, I'm not getting back a 200 code as the response code, and the code turn the screen color, the background color, to yellow to reflect that, hey, we got a problem here. I'm not getting back what I'm supposed to get back. Are there any questions about this application up to this point? We are not even getting the data yet, right? We are just kind of playing with the response code and how to get the document. So if the document is okay, then we can do some further processing, after this block here. So let's switch back to the notes again. And that's the old way of doing it. It has the same type of blocks, but we're still doing the same thing. It's just that it looks a little bit differently. The slots are a little bit different. And this is what we are supposed to get back. If I make this code like this, the response code is going to be 200. The response type is text/HTML, and then the response content is actually the entire document, including the head, body, and so on, all the elements. Okay. Let's go ahead and do exactly that. Okay, because I want to kind of follow my own experiment a little bit here. So we switch back to this block here, and then we'll use the text box 1, 2, and 3 in order to display, okay, what are we getting back? Okay, so we'll set text box 1.text to response code. Give me response code. And then we'll set text box 2 to the response type. And as we get the result back, I'll explain, the significance of each one. And then we'll use text box 3 to show us the actual content. What is the file? What is the actual response that we're getting back? All right. So now this application is very closely mirroring what you're reading, in the notes here. Let's switch back to the emulator and just run it again. Oh, I forgot to switch the fix my URL. There we go. And switch back to the app. All right, so we're getting exactly the same thing back as what the notes said we should be getting back. 200 as okay. Okay, we explained just that part. What about the second one? What about text/HTML? Well, as it turns out, HTTP, which stands for Hypertext Transport Protocol, can also transport things other than HTML. Okay, it's not just hypertext they can transport. It can transport just about anything. But in this particular case, we have text./HTML in this box here, which means the server is identifying to me as the client. This content should be interpreted as an HTML document. Okay? And as a result, when I look at the actual content, these are elements in HTML. Head is an element, body is an element. If I have any further HTML document elements, it will all be shown on one single line. Okay, because that's the content of this particular file. Okay, well, that doesn't seem too bad. It doesn't seem too bad until you have to deal with the actual body. Okay, I think you may not be able to see it very well, but I'm hoping that you can see at least, the boundary between the body, which is the open tag of the element, and the actual content that I want to get to. I really don't care about head and then the /head. I really don't care about body and /body. I only want to get to value 1, value 2, value 3, and comma separated. That's all I really want to get to. So all the tags, open tag and end tag of HTML is really getting in the way. I mean, I don't want to spend my own logic to parse the HTML document just to extract the one portion that I want. Okay? Does everybody understand why even though it works, it doesn't work very smoothly? It has some additional things that I don't want to do. Okay. So let's go back to my notes here. The solution is actually pretty simple. Okay, there's a solution to it. The solution is don't use HTML. Okay, if you do not use HTML, then there won't be a head element and there won't be a body element. There won't be HTML tags that you have to process. So the alternative is to switch the document type to what we call a CSV file, okay, a comma separated value file. And I'm using a script to generate the same thing basically, because I haven't found another way to do this very easily, but this is one way to do it. This is a Perl script. I'm not sure whether PHP can do the same thing. The most important part is in Perl, I can easily change the type of the document. Instead of using a text/HTML, it is now a text/CSV, which means the server is going to identify to the client and say, okay, here's the response, and it is a comma separated value file. Do not try to process it as an HTML document because it is not. Okay? And then once I identified that this is not an HTML document, it can simply give me back exactly the 3 values that I'm looking for. Just value 1, value 2, value 3, separated by commas. That's all I'm going to get. let's see if this works. So we'll go back to the document here. Let's switch back to the code. Change the URL. Instead of data.html, it is data.pl, which is the extension of a Perl script. And then switch back to the emulator and get everything back. And you can now see that we are still getting 200 as the code, as the response code, because the request went through without a problem. I retrieved the resource that I was looking for. But as far as the second field is concerned, it's a little bit different this time. I pressed the buttons. Let's see, if I use home, should be able to get back to the application. There we go. Okay, so it has two components this time. This is the second component. It identifies what type of what is the character set I'm using here. And then the first part identifies this is now a CSV document, which is a comma-separated value document. And I'm just getting back the content of the document, or the content of the response is really just value 1, value 2, and value 3, comma-separated, with none of that nonsense of HTML tags, open tag, and close tag, and stuff like that, which makes parsing a whole lot easier on the app side, because I don't have to filter all the other stuff that I don't need. Are there any questions about this part here? Because we just switched the document type from HTML to CSV. And since I did not display the document as an HTML document, I have no reason to use HTML as the format of the response. A CSV format is far more appropriate in this case. Any questions about this part? No questions? This is all good? All right. Okay, now that we have value 1, value 2, value 3 as a response as one single string, okay, it is one single thing, because according to this code here, I'm just getting the response content, and that's, the comma separated, text here. What am I going to do with it? Okay, because I probably want to separate, value 1, value 2, value 3 into 3 individual components and process each one individually. Okay, so how do I do something like that? So what we'll do is I'm going to change this code here. So I'm going to get rid of get response code, because we know what it does already. We're going to get rid of response type because we just talked about it. So we'll now focus on response content and say, well, what are we going to do with this response content? How do we process it? This is also a good time to kind of illustrate, one feature that will be handy. I know it's a new feature, especially if you're taking CISP 300, 301, or 370 at this point. I'm going to talk a little bit about procedures. Okay, a procedure is a very handy way to contain a little piece of code so that your program or your code becomes easier to read. You're basically just saying, oh, to process the content, go here. This code is responsible to process the content. Okay, so from the other place, you just say, go ask that block what to do. Okay, I don't know exactly the details. I just know, okay, that person knows. Okay. So this is called abstraction. It is a way for you to defer the detail of processing something into another block of code. It is particularly handy in App Inventor, because if you have any type of long block of code that can get lengthier and lengthier, it is really a hassle to have to move all those blocks around a lot. So it's not a really good idea to do that. Now, to create a procedure, or what we call a subroutine in other classes, or function in C and C++, you first have to change the name. Okay, so instead of calling this procedure, which is very generic, let's call that something that is a little bit more descriptive. How about just say process response? Okay, we'll call it process response. That's just the name of the subroutine. In other words, now I identify, okay, this is the name of this particular subroutine. It has a name, and we can just refer to that with the name. The second thing we can also specify is, what are we processing here? What is the input into this procedure? By default, it has no particular input. We'll go ahead and make one. And the name of the input can also be changed. It has a very generic name of X to begin with. So we'll change this to response, okay, or response content if you want, to match the name of the of this particular component here. All right. So now we have something that we call a procedure. Okay, a procedure looks like an event handler, but it's not, because we don't see the when word within the block, right? So that means this is not something that is triggered by an end user or a web server responding to an application. This is responding to someone explicitly calling and say, hey, process response, I got something for you to do, and it has to come from within your own application. In this case, it cannot be come from outside, it has to come from within your application. So let's go ahead and find out, okay, but how do I get this block to execute? How do I get it to do some work? Well, let's get rid of this one here. I'm not going to set the text box directly in this case. So we go back to procedure here, and now we have a new block, right? This wasn't here before. The new block is to say call and then the name of the procedure, and then with a parameter of something. In this case, response content is the name of the parameter. So we'll put this block here into this part here, which basically means, okay, if the response is okay, we got everything here, then go ahead and call this. This is basically how we trigger the execution of this block here. When this block is done, it goes back to whatever is after this block. Are there any questions about the mechanism of calling a subroutine, and when the subroutine is done, it just simply goes back and continue with whatever is after the call block? No questions about that? Okay. But it's a clean and easy way to simplify this block here, because all it says is, okay, we got the content is okay, go process it. Okay. But how do we process it? All the details of processing is going to be here. So this way, it just makes your code easier to read. Okay, so now that we have this block here, how do we process the content? This content, response content, is still going to be the comma-separated list. Now, when you look up lists, all the blocks related to a list, you will find something that is extremely handy to what we are trying to do here. Scroll your way down a little bit. And the last few blocks here, okay, not exactly the last one, but there are 4 of these that are kind of related. The first one is called list to CSV row, which is not what we want to do. It's kind of opposite of what we want to do. Okay, you start with a list, and it will give you a row of CSV or comma separated values. That's not what we want to do. It's opposite of what we want to do. List to CSV table. Okay, in this case, we have a list of lists, and it will give you rows of CSV rows. Okay, that's not what we want to do. This is what we want to do. We want to recreate a list from a CSV or comma separated value row. That's what we want to do. All right, but you can see this notch here. It's saying, okay, I'll give you a value, but somebody better know what to do with this value. Okay, fine. So what we're going to do is to have a local variable so that we can store the list that is coming back as a result of list from CSV row. So we'll have a local variable, and let's just name it value list. Okay. And that's going to be a list which is the result of using list from CSV row. What is the text that I'm going to use to create this list here? I'll let you guys tell me.
Text box.
Well, I don't use text box 3 anymore. Okay, what is the input to this procedure?
CSV or text.
Response content is the name. Okay, response content is the name of what we call a parameter, which is basically saying, okay, when you want to process, the content or the response, this is what you're processing. Okay, so in this case, this name here, response content, is what I'm given with to process. So this block here, okay, if you read this block here, which is kind of long now, I'm creating a local variable value list. So that means value list is only usable within this block here. Okay, it is not even visible, outside of this context. But how are we initializing the content of this value list? Well, we are using this blue block here to convert the text which is my response content, which is value 1, comma, value 2, comma, value 3, I will turn it into a list. And that list in return is stored as value list. Are we kind of doing okay so far? Okay. Now that when I get into this block here, value list will be a list with 3 items, okay, at least in this particular sample program. So with those 3 items, I can now change the text of each text box. So text box 1 is going to get the first piece. So I'm going to set the text of the first text box to the first item of a list. To get to the first item of a list, you have to go to the list drawer here, and then pick out the right blocks in order to select one particular item, which is select list item. And which list are we selecting an item from? What is the name of the list? Value list. Okay, exactly. So we'll basically hover over value list until it gives me the 2 blocks that I can select from. And the index is basically saying, okay, now that I know that you want me to get you an element out of a list, and you have given me the list already. But what is the position of the item that you want me to retrieve from this list? It starts with 1, not 0. Okay, so the first item is 1. So in this case, I'll just give it a constant of 1, because that's the first item that I want to retrieve from that list. So we just put a 1 here. And when we have this, we can just kind of, not copy and paste, because I don't think it allows me. Oh, it does. Okay, so we can just do a duplicate here to deal with text box 2. And text box 2 is going to handle the second element in the list. And then we'll duplicate this one more time to get to text box 3, which will handle the third element of the list. Are we doing okay so far with the rationale of the code? The details, you don't have to worry that much. I mean, the lecture is getting recorded. You can just replay all the steps. So it's the concept that is important. Are there any questions about the steps that I have done so far, or the rationale, what I'm actually trying to accomplish here? Questions? All right. If there are no questions, the first thing I want to do is to double check that my recorder is still up and running, because that would be a problem if I promise you one thing and it's not getting recorded, right? So it's good to double check. All right. So now that we know it's getting recorded, let's go ahead and check it again. Okay, so we'll click Get Data. Uh-oh. Attempt again. Okay. Well, I need to check my script then, because maybe my script is not done correctly.
Should she be passing something to response content?
Sorry?
Should she be passing something to response content? Inside Apache app?
Inside Apache?
No, in the app.
Inside the application?
There's nothing being, unless I missed you putting it in, there's nothing being passed to response content. In the when
Oh, right. Okay, this notch is not filled. Okay, thank you. And I did not do the one thing that I think everybody should do, is to read all your warning messages. Okay. Now you guys won't feel the irony of this, because you're not in my next class. The next class is cisp362 C++ programming, and in that class I preached every single day that people should pay attention to warning messages, and guess what I did? I just ignored. Okay.
you gotta listen to yourself.
Yeah, I should listen to myself a little more.
You
But then I have to choose which
parents.
voice I have to listen to. That's a tough one too.
You have
Okay.
a lot of parents that will be praised.
Yeah. Okay, so I'm gonna pick this, which is a parameter from the event handler itself, and I'm gonna use it to specify it to become the input to the procedure or the function or the subroutine that we call process response. Okay, so now it makes sense, okay, because before it wasn't processing anything because I did not give it anything to process. Now it does. Okay, so we go back here and say get data, and we got value 1, value 2, and value 3. It got the comma separated value row, and it chopped it down into the components and stash it into each text box, accordingly. So are there any questions about this little kind of simple app here? Okay. What is the big deal? We just got like 3, simple items from a web script. Okay, what is the connection here? The other side. Okay, let me just switch to the other side first. Okay. I mean, if you look at this code here as a Perl script, it is definitely not a complicated program, right? All it does is to spew out, you can, even if you don't know, HTML or Perl, I mean, this line kind of does what it claims to do, right? It prints something, okay? It prints whatever is in the double quotes, value 1, value 2, value 3, \n is a line feed character, and that's it. That's all it does, okay? But you can replace that part with a 200, 2,000, 20,000 line program that would spill out something after computation with a comma separated list. So you can push the logic of your application onto the server side. Okay, the application itself is nothing more than a relay. Okay, I'm a form. Okay, here is a text field, here's a checkbox, this is a list box and whatnot. When you click the button, your application doesn't do a single thing about the processing. All it does is to format a URL, send it over to the server, and say, okay, it's up to you to process. Let me know when you're done. The server will do all the processing. That's your 20,000 line Perl program doing all the processing. It comes back with a simple response that has like 3 items, comma separated. And then your app will take those 3 items and say, okay, I know what to do with these 3. I will display this one here, display this one over here, and that one over there. That's it. That's all it's going to do. Okay, so you can make your application that way by pushing all the logic onto the server side. The nice thing about pushing all the logic onto the server side, there are several. The first one is you don't have to worry about, well, am I going to have enough storage on the application to store all this data? Nope. Well, it's on the server side, right? You can always step up the resources on the server side relatively inexpensively. But the best one is, what if you change the logic? What if you find that, oh, okay, I made a mistake here. Let me fix it. None of the applications on the server, on the mobile side, needs to be updated because the logic is not on the mobile side; it's on the server side. What if you drop your cell phone when you're getting into your car and then subsequently roll over your cell phone? Would that destroy your data? Nope, it's on the server side, right? So there are a lot of benefits of doing it this way, at least storing the data on the server side, but you can also push the processing onto the server side. There are quite a few applications where they push a lot of stuff on the server side. Wolfram Alpha is one of those. Okay, Wolfram Alpha, let me show you what it is. It's Wolfram Alpha. And it's, this is the web interface to Wolfram Alpha. It's also an application with a similar interface. And you can say distance to the moon. And it will show you not only currently what is the distance between the moon and the earth, it will show you the graph. If you click on any point, it will show you output soon, subscribe to Pro. No, not going to do that. But if you have Pro version, it will show you that too. If you it will give you the equations, it will give you all kinds of data. Okay, well, if you have the application installed on your phone, on your mobile device, you'll get the same response. And you'll ask, but how can we store that much data about just about everything on a mobile platform? But it does not do a single thing. All it does is to give you a text box, and then whatever you type in the text box, it sends it back to the website, which probably has like racks and racks of servers to do all the processing to basically answer your question. Okay. Now this is really the way to do things. How many people know what is IBM Watson? Okay, some people know, some people don't. Okay, but let's. Yeah, I'm using this as an example. Okay, I'm not saying that you guys will write your own Watson in the near future, but if you look up Watson, it's basically AI. They don't call it AI because IBM, knowing IBM, they will never call anything intelligent. But even though it is, okay, it's basically a way to interact with the computer by asking the computer questions. Just kind of like Wolfram Alpha, except in this case, it can be just about anything, okay? And not can it doesn't just answer the question, it can do some reasoning as well. The original purpose of IBM Watson is to play the Jeopardy game. Okay, which it did and won, right? I think it beat all the human players.
It did, and then the final round was down.
Yeah, but it's still an accomplishment. It's still a really major accomplishment when it comes to computers. So that's the reason why I'm kind of telling you guys, okay, yes, this is not exactly Watson, but it shows you what can be done once you push things onto the server side. Okay, the rest of this program is really just repeating what I said a little bit earlier. Okay, it's a little bit different. This time I didn't use the concept of a procedure, so I'm basically putting everything within the when get got text block here, which makes it kind of bulkier, but it does exactly the same thing, and it chops it down into value 1, value 2, value 3. Okay. If
at least the way you're doing it is if we have multiple ones we're doing, depending on what button we press, it's going to call them for different locations. So if you had a data 2.pl, 3, and so on.
Yep, exactly. And also, this also makes cross-platform easier because you're not doing a whole lot of logic in App Inventor. When you move on to the next class, you just have to learn how to do it in Java. If you try to port your application to the iOS platform, you just have to know how to do how do I formulate an URL in Objective-C? Okay, how do I send it to a website? How do I process when it comes back and process that comma-separated list, comma-separated value row into a list? And trust me, almost every single platform has a simple way to do all that, simple text processing. So that makes porting an application a whole lot easier because you don't have to re-specify the actual logic of doing something in Java, in App Inventor, in Objective-C of iOS. Okay? You're pushing all the logic, all the complicated stuff onto the server side. Then you can choose whatever you want to use. On the server side, you can use Java, you can use PHP, you can use Perl, you can use Python, you can use Visual Basic. There's a whole host of programming languages that you can use on the server side, which is independent to the client side. What if you decide, oh, okay, I want to expand my application by making it also available to desktops? You build your HTML document around the engine. So now your HTML document or whatever script you want to use does not contain the logic. All it does is CSS, table, put a few things on the screen and make it look nice, and that's it. So it makes it very easy to make something, whatever application that you're trying to design, cross-platform compatible with minimal effort. And this part here, talks about how to process multiple lines. We are just, instead of giving it one single row to process, now we have multiple rows to process. And to process multiple rows, you basically use a split first, and then after a split, you can still get to each individual item. So not really a whole lot of difficulty here. Are there any questions about what we have just talked about? Let me go back to the code so that we can take a look at it. Let's see if you guys have any questions. Any questions about the rationale of what we are doing here, which is actually more important than the individual blocks? What does this block do? What does the other block do? What is the rationale? Why are we doing this? Are there any questions about the rationale of doing this? Go
I
ahead.
just have a question. What if you wanted to do some math on the values?
If you want to do some math on the values, well, you can do it. There are a few places you can do it. After you get to, okay, you can take this block here and then do whatever you want with the value that you're giving back. So if you want to do some math, you can put it into a plus block or to one of the two slots of a plus block, and then you can do addition. Because what is returning here from this block here is really just whatever that text is. Okay.
It's kind of like it's passing it by value, not.
Right. It is just returning the value of the third item of this list. Now, in this case, it's value 3, which is not a number that you can do math with. But if it is a number, yeah, you can go ahead and use it as a number. Use it in whatever calculation you need to do. Any other questions? If there are no other questions, there are a few more slides or a few more documents that I have prepared on this particular topic. The next one is JSON serializer and remote database, which is connecting what we have done today with what we did last time. Okay, because everything is kind of tied in. Okay, last time we talked about a JSON serializer, which is basically a mechanism so that you can pack a structure, a list that can potentially contain other lists into a single string. Okay, that's why it's called a serializer, because you're turning something that is not serial, not linear in its nature, into something that is just linear. Okay, it's just a sequence of bytes. Okay, that's what a serializer did, is to turn something that was not in sequential into something that is sequential. It's really just text. Okay, so. And today we talked about remote database. So how do these two concepts relate? Well, as it turns out, they are closely related. They kind of help each other in many ways. Okay. So accessing a remote database is a big step to, yes, I invented that word. Well, not invented, but I made up that word. Probably already existed. Many people probably already call that, use that word to refer to the process of making an app cloud-based instead of completely local on the mobile side. So I just called it cloudifying, okay, which is not making, okay. Well. So in this case, a database, for those of you who know what the database is, you already know this answer. For those of you who do not, well, I'm going to give you the answer. What a database can do is really complex, flexible, and powerful. But what you can store with a database is kind of boring, okay? Because for the most part, you can store, well, text, okay? Strings, address, first name, last name, that sort of thing. You can store numbers, okay? Well, numbers are very exciting, but they're numbers. And then you can also store, well, let's see what else. Dates, okay? Time, date, and that sort of thing, in the database. Great. But what about a list? Okay, well, you cannot really store a list in a database, not natively. But what the best part about this is we already talked about how to turn a list, a structure, into a string. And all databases can store strings. So now we have a way to store an entire structure into a database. Okay, that's how those pieces are connected. Now, before you say, "Oh, great, I can use JSON or serialized structure using JSON to store something," well, let's go ahead and slow down a little bit here, because in order to prepare a database, a table to store JSON text, you have to choose between the types of that field or that column. You can use a char or varchar column for storing text. You can also use what we know as just regular text as the type of a column. The difference is kind of subtle from the end user's perspective, but it is major from the implementation perspective. When you use char or varchar and then use parentheses to specify up to how many characters you want to store with a particular field, it usually will reserve up to that much space per row in the database. So it's not really a good idea to say that, oh, this can be up to 64 kilobytes long when most of the time it's only like 3 bytes long, because you'll be wasting a lot of space in your database. Okay, a text field, on the other hand, has a mechanism where the actual text is stored in a different file. So it would be far more storage efficient if you use a text column to store something that can potentially be very long or very short or be empty in general. Okay, so for JSON text or serialized JSON text, it is usually better to use text text as the column type instead of a varchar as the column type. The only one thing that you might not want to do with the text field is to search it or to use it as an index. Okay, because it can potentially be very long. So if you want to use it as an index, it's not going to be very efficient. You might be able to do it, but it's not going to be efficient. When you send something over, as JSON text, you will have to encode it also using HTTP. So I'm not going to read the description or the details here, but we have now 2 types of encoding. And how do they relate to each other? Do we really have to do both, and in which order? Okay, those are the questions. So instead of just using the whiteboard here, I'm going to use the instead of using the projector, I'm going to use the whiteboard a little. So we'll go ahead and start with a list. Okay, a list typically starts with a parentheses. That's a standard notation. So I'm just going to say v1 is value 1, v2 value 2, v3 value 3, close in parentheses. So now we have a list of 3 values, v1, v2, and v3. So the first step we have to do is to convert it into a JSON notation, which is, well, that's redundant because JSON stands for JavaScript Object Notation. So it is redundant to call it JSON notation because notation is the last word of JSON. Okay, so when we use JSON to encode this, it becomes open square bracket, which is what JSON uses to denote the beginning of a list. Double quote v1, because v1 is a string, comma, which is what we use to separate between items within a JSON list, v2, double quote, comma, double quote, v3, double quote, and close bracket. That's JSON encoding. But you cannot transmit this, over to a website because HTTP, the Hypertext Transport Protocol, does not like these, special, characters. The comma, the double quotes, and also the square bracket doesn't like it. Okay, so you want to, you have to use HTTP to encode it. So now you use the result of the JSON encoding and pass it through HTTP to encode it into what HTTP would like to see. And I'm not sure whether the square bracket can be done. So let's say the square bracket is okay, but double quote is certainly not okay with HTTP. So that's why the double quote gets converted into ampersand, QUOT, and then a semicolon. V is okay by itself, 1 is okay by itself, and then the end quote is also going to be ampersand, QUOT, and then a semicolon. I think comma is not okay within HTTP. Does anyone know for sure? I cannot remember. Let's check. But that's the process. Okay, we are taking the output of JSON encoding and then encode it using HTTP before it can be transmitted using the web component. So let's take a look at HTTP. That's not it. Okay, URL encoding reference. Oh, try it yourself. That's what we like. That would be enough. Okay, so when you're transmitting this, as a request, this is how it wants to encode everything. The %5b refers to the open square bracket. %22 or %22 in hexadecimal refers to the first double quote. And then we have the V1. This is the end double quote of the first part. %2c is the hexadecimal representation of the Comma ASCII code, and so on. So this is basically JSON text encoded again using HTTP before it can be transmitted. Okay. So do we have to specify the logic to do all this nonsense stuff? When we look up the ASCII code, put in all the % symbol and stuff like that? Nope. The web component has abilities to do it already. Okay. So I've just kind of spent the last 5 minutes just outlining what we can use, using the web component. Within the web component, there are several things you can do, with the calls. When you are sending something that is already JSON encoded, you can send it using URI encode. In other words, you give URI encode the JSON text here, and will come back with something that you can transmit as a part of a URI or URL. Okay, and that applies to all the parameters of a web page and stuff like that. When it comes back, you can also decode it by using HTML text decode. So that will decode something that is encoded using HTTP back to the original text. And if that original text is JSON, then you pass it through the JSON decoder. The JSON decoder is also a part here, JSON text decode. So it's already here. The only part that is missing is JSON encoding. And we just talked about it last time, right? A week ago, we talked about how to do JSON encoding. So now we have the whole set ready. JSON encoding, and then HTTP or URI encode. And then on the way back, we have HTML text decode, and then you pass it through JSON text decode. So this way you can basically transmit anything you want. You can store anything you want in the database, including a list with 20 gazillion things and with nested structures and whatnot. Are there any questions at this point? No questions? We got 2 more minutes, okay? Before anyone is getting very excited and go, okay, I'm gonna make my website, I'm gonna make my web engine to do all the database things. Okay, this is something that we didn't quite get to today, but it is also very important. Security issues. Okay, you got to make sure that your database is not exposed to people who are not supposed to access the database. Okay, and also remember, your application is going to be installed by different people. So unless your application is going to share the same data across everybody who's using it, which is okay. I mean, there are certain applications like that. But if your application has anything that is on a per user basis, you have to make sure that you can get the authentication part secure first. In other words, you don't want one user to be able to access the data of another user. Okay, and there's a whole big discussion of all that stuff, because you have to deal with server security, make sure the server is secure. You have to deal with web script security. This is a big one because a lot of times the server itself is secure, but the script is not. And as a result, an entire database can be exposed. You have to deal with authentication security. How do you let someone log in? You don't want to transmit the username or the password in plain text. Okay, so at least go through HTTPS. And also, what if the mobile device is compromised? Okay, do you keep the session on all the time, or every time the user starts the app, the user has to re-authenticate? Okay, so those are the questions that you have to answer. And for those of you who cannot wait until the next class and you really want to get started, there is some additional stuff here too. You can also look into how to use sign in with Google. Now that, I think, is a really cool feature because it pushes all the responsibility of authentication to the Google website. Okay, and many places are starting to use that already. Does anyone know wood.com? How to use Wood? No, sort of. Okay, so when you use Wood, you can authenticate using your Wood ID, or you can use your Google ID or your Amazon ID to sign in. So now the authentication is not done by Wood, but it's done by either Amazon or Wood or Facebook and etc. Okay, so that's really a common trend of how people want to do authentication, is to push it to some other website to get that part done. So I got 2 links here. This link is interesting because it has a no free lunch philosophy. When it's time to actually talk about how to get it done, they want your money. Okay, there's a PayPal link to it. Yeah. Well, if you don't feel like paying someone to do that, you can also read the OAuth. I guess it's object-oriented authentication 2.0 document, which is on the Google website, and implement the same logic in App Inventor. It can be done. It's just a matter of how much time do you want to spend to get it done. Okay. So I'm gonna end today's lecture at this point, and just kind of leave this as a quote-unquote cliffhanger. Now, for your projects, you don't have to push it this far. Okay, you just have to show me, this is mock-up data. Okay, I just have a script to spew out some of these random numbers or whatever string or whatever that is doctored, and that's okay with me. Okay, but I do want to give you all this information in case you want to push your app, kind of beyond the envelope of what we want to talk about in this class. All right, I'll see you guys on Wednesday.